All right, so let's go ahead and look at a few things here. So looking at what I have, when I see that this is a negative sign here, I do know that this is going to be a hyperbola. And then the other thing is that I see what I have here. This first term is my positive term. That is my y. So what this tells me, this is going to be transverse to the y-axis. So the long side of my hyperbola is going to be going this way, and my parabola is going to be opening, hyperbola, excuse me, will be going up and down. All right, so let's go ahead and give me some values here. Because the value underneath this is 16, I know that a squared, we'll change that back. I know that a squared is equal to 16, or a is equal to 4. Over here, my b is equal to, b squared is equal to 4, so b is equal to 2. So if I go through and find my c value here, my c squared is equal to my a squared plus b squared, or 16 plus 4. So c squared is equal to 20, which gives me the fact that c is equal to the square root of 20, which is 4 times 5 under the radical, or 2 square root of 5. Okay, so next up what we have to do is we have to go through and find the vertices. And of course the center. So let's go ahead and start with the center. The center of this, just watch this. Remember, the center is still always going to be my x value and my y value. So my center here is at 2, 1. So after I find my center, it's important to look at what's going on here. My x value of both of these for my vertice is not going to change. That x value for both cases is 2. What changes is the y value, and that's because this is, again, this is my up and down hyperbola. So what my y value becomes here, my y value is just that 1 plus the number underneath it, so that's going to be 1 plus a, or 1 plus 4, which gives me 5. For my second vertice, it's going to be the same thing. It's just going to be 1 minus that a value, or 1 minus 4, which gives me it to be a negative 3. Next, we'll go through and find the foci. The foci are the same way. What I mean by that, they are in the same direction, so that x value stays that same. So the foci is going to have the 2 x values at 2. So again, my x value or my h value of the center stays the same, but the y piece of this is going to be the k value, or 1 plus c, excuse me, plus or minus c. So then that gives me my foci at the first point would be 2. My y value is 1 plus 2 square root of 5. And my second one is 2, comma, 1 minus 2 square root of 5. So that's it for all the points that I have to. Let's go ahead and copy all of this information over so then we can go ahead and graph the hyperbola. Okay, so when I went ahead and copied them over, I did go ahead and turn the foci, the y values, into decimals to make them a little bit easier to graph. So my center of this hyperbola is at 2, 1, which is right about there. The vertex is at 2, 5. And then again down below at 2, negative 3. Now, let's go ahead and plot those foci. The foci, again, they're still along that same line this line down here, which is x is equal to 2. That's why all of those x values stay the same. So my foci are at 2, 5.5, and down here at 2, negative 3.4. So just a tiny bit larger than the vertices. They're very, very close together on this particular graph. The next thing I need to do is I need to go ahead and draw in my box. So the idea behind this is that I knew that A was equal to 4. That's that distance between here and here. Same thing here. Going out in the other direction, B was equal to 2. So I want to go out 2 in this direction and then 2 in this direction. That will go ahead and give me that box that I want to go ahead and create, so I can draw in those asymptotes through the diagonals of this. So then I'm going to have a diagonal asymptote here and a diagonal asymptote going the other way. And my graph will open up and graph will open down. Now, the equation, the asymptotes, one last piece that I need to say in there, this is going to just be y is equal to 1 plus or minus 2 x minus 2. Where does this come from? This is just the fact that y is equal to k plus or minus a over b times x minus h. And I think that one is the last hyperbola on this worksheet.